Hey guys, welcome to the start of another project. I already did a part one where I took a look at this set. Now we're really going to dive into it. This is a Zenith porthole set, 12-inch tabletop variety. I also recently talked about a Dumont. I ordered up parts for both already, the same owner for both sets. I basically flipped a coin. This set won, at least for now. We're going to start working on it. I'd say they're about on par. Maybe the Dumont's a little bit more complex, but they're both going to be a bit of work. Probably because I haven't worked on either one of these before, or either a chassis by either one of these companies before, but also because they did things their own way. Zenith and Dumont were big enough that they had their own engineering, R&D staff, and especially Zenith. Well, as we're about to see, there are some distinct oddities to this set. It was filthy, if you've seen the first part. I've seen worse, and it's not corroded, but it had a nice layer of dirt. I've already cleaned off most of that. So let me give you a fresh tour of the chassis now that you can see things better. I still have a little bit to do in this area, but I got the worst of it out, even cleaned up the tubes, and they also gave me a chance to examine things in more detail. So what's so different about this set? Well, right off the bat, metal cone CRT. The front of it is glass, phosphor, coated, just like any other picture tube. But from the front to this point is spun metal. I don't know exactly how they made it, but that's the term that they use, spun steel or something like that. I've had a couple duds. I've busted these open. It's not super thick, but not real thin either. I think maybe, I'm looking on the lip here, you can get some idea. It's maybe a 1/16 of an inch thick. But it's certainly lighter weight than glass. That's why they used these. The whole picture tube probably weighs half or less than an all-glass version would. Also allowed them to make bigger picture tubes, I believe, more easily, all the way up to the gigantic 30-inch Dumont CRT, also metal cone. So what's the downside? Why didn't these proliferate? Because they were only around for a couple years. Well, one, here's our high voltage lead. It clips right on the metal cone. From here to here, this entire thing is high voltage. No insulation. You don't want to get anywhere near this thing when it's turned on. The other issue is the glass to metal seal. They did their best to match the coefficients of expansion. They both change slightly with temperature. But in extremes or from vibration, the seal can break and air can leak in, either around here or up around the faceplate. Not many manufacturers use these all that much, especially the 12-inch. This is a 12 UP4. I think Zenith is the only one that really used it to any extent. And they also made an all-glass version of this set, and they sold it at the same time. I'm not sure if there was a price difference or they realized that maybe this wasn't the greatest idea. I don't know. Which is another problem. Not just when you're working on the set and you're standing behind it. From the user's point of view, you get near the front of this, you can tell there's something going on. They put this thick plastic insulation around, but you get a bit of a static buildup, especially on the larger 16, 19, and bigger versions. It's weird to be around them. I'd prefer not to take this out, but maybe I should for safety's sake and use this little test CRT. I just don't want to mount it because of the extra insulation. It's a little bit more complex. Anyways, we tested it. It tested really, really well, so fingers crossed. If it did burn out, a 12 LP4 is similar. It's not exactly a drop-in replacement. Dimensions are a little different, and you're going to have to modify the front to support it because I don't think it fits inside this plastic quite right. Anyways, let's not worry about that till we have to. I really cleaned more thoroughly on this side. Most all the tubes have been replaced. I believe this is a Zenith, and I think the 5U4 is a Zenith. The rest are not. I thought this was curious. It's a 6SN7, but it has a metal base. It's a W type. I'll have to see if that's really required or not. I presume this is grounded to add some shielding. I'm not... The Success on 7s, the vast majority I've ever seen look just like that. They just have a plastic Bakelite base. This is also mounted on a bit of a shock mount, so maybe that is a special requirement. Similarly, this is a damper tube. Notice the socket's a different color. This is a special type of socket that can handle the higher voltages that will be present on this. Oh, that's an original. Odd that of all things, the 5U4 and the damper tube, two of the tubes that get worked the hardest, may very well be originals. The one tube I took out here should be a 19 BG6 horizontal output tube. I took it out, well, for a very good reason, which I will show you as soon as I remember where I put it. Ah, here it is. Keyway's gone. The octal, the plastic bit they would stick down through the middle and tell you how to orient it in the socket, or force it to be oriented in the socket correctly, is gone. It's also a much newer type. I have a good supply of 19 BG6s in the Coke bottle style, so I will dig up an old vintagey one to put in there. It'll look more periodly correct. So, there's another oddity. This is the flyback. This is the high voltage circuit. It's not enclosed. It's just sitting out here for the for your shocking pleasure. So, high voltage rectifier horizontal output tube. They just clip on here. So, in addition to this whole thing being high voltage and this wire being high voltage, this whole area is just wide open to the environment. Yikes. Oh, what else? This comically large tuner. I think there's a nickname for it, like a Ferris wheel tuner or something like that. There is a huge Bakelite plate here for each channel. About that wide, this long, that has various coils and caps to form a bandpass filter and have the local oscillator component values for each channel. And this will be your typical trio of tubes, which would be an RF amp, local oscillator, mixer. Oh, that's it, I guess. We have a 3 BJ6. It's probably a 6J. No, I can't quite tell. Anyways, that's what the functions are: RF amp, oscillator, mixer. Why it's so big, I have no idea. It takes a lot of effort to change channels. There's this huge bearing down here. It's a ball about 3/8 of an inch in diameter with a piece of spring steel behind it. Just so, this is about twice as large as the next largest tuner I think I've worked on. So inside this box will be the components to power and work with these tubes. And then there'll be contacts underneath here as each plate swings by. Nuts. Here's another crazy thing. We have a big old power transformer, right? However, it's a series strung set. And it's half hot. What do I mean by that? Well, we have a bottom portion to the chassis, we have a top portion to the chassis, and there's a phenolic insulator in between. The top side will go to one side of the power line. Bottom floats. Don't ask. Because again, they made other versions of this chassis for 12-inch, 16-inch sets that was not series strung, and they used filament windings on the power transformer. It says right on the side of the power transformer, it's 170 watts. I have to refresh my memory, but I believe this is for B+, and I think some of the tubes, like the CRT and maybe the damper tube, are powered from windings on this. But the rest of the tubes, so we have a 25W4 damper tube, a 19 BG6 horizontal output tube. I think we have some 3-volt tubes in the tuner. Those are the major oddities. Some other little tidbits, like we have a tube mounted at 45 degrees here for some reason. There are odd cutouts in the chassis, like a wire wound trimmer here. some core there, another trimmer here. I assume those are all for adjustments. Oh, and then there's this. So, normally the tuner would be mounted up front, and there'd be some sort of access point so you could feed in a tool to tweak the local oscillator slug for each channel. In this set, they do it with this gizmo. So this you push in, and it will engage with something inside here, and you can adjust, I presume, a slug or a variable cap. But normally the spring kicks it out so it's not engaged with anything. Fine tuning, unfortunately, broke. It's up here, and it should go down to a pulley down there, and it's actually a control behind a panel, I think, on the front. This is the fine tuning control. It's not around the channel clunker, which is how you normally would do it. For example, here's an RCA set, channel clunker, here's the fine tuning. That's normal. This is not normal. I think the thinking is, if it's set up properly, you shouldn't need to get at the fine tuning control. So they made it somewhat inaccessible, and then the pulley arrangement. Boy, I hate dial stringing, but I'm going to have to deal with it. The electrolytics, I was a little confused at first because I just saw the one, and I was wondering where the others were. Well, they're right directly underneath the CRT yoke, so not the most accessible things. There is a little bit of damage. There's a big lucite block underneath this. Of course, this is high voltage with a big insulator, and there's supposed to be a spring. You can see the shadow left by it. It's supposed to hook onto this, wrap around, and hook on the other side. The other side's broken off. It's a real common issue. I might be able to glue it, although I don't think I have the missing bit. So I think another collector might have one for me. I'll see. Or maybe at the early television convention I can pick something up. I do have a parts chassis that's very similar. This part is missing or broken on that, but if there are any other bits and pieces I need to scavenge, I may be able to get them from that. The AC interlock is a little odd. It's polarized, apparently. Locks into the back, so I'm going to have to rig something up. My normal cheater cords will not fit under that. I think the spacing might be a little different. I certainly have polarized cheater cords, but let's see. The spacing looks a little wider. Yeah. If need be, I can just cobble together a connector with a power cord. Just use some brass tubing or some push-on Molex connectors or something. I'll rig something up. And let's see, finally, I believe this goes to the speaker. A very, very long, convoluted path. That should be the audio output transformer. Odd how they packed all this stuff. And basically all the power stuff is over here, and the RFIF stuff is over here. So right next to the exposed high voltage, we have the audio output stage. Well, the die has been cast. I have replaced one capacitor. I had to start somewhere, so I picked one that was readily accessible and I could read the value on. It's a .047, so got that installed, and I did verify it on the schematic before I touched it, or before I clipped it out. This is the factory service manual for 1950. I don't think it covers all the 1950 models, but it covers the ones that have all this basic chassis design. There are several variations. Mine is the 23G22, as near as I can make out. There are subtle differences, so you do want to make sure you get the right one. Now, I was off a little bit about the power transformer. It's a little confusing. Everything's a little confusing in this set. So here's the transformer. We have two rectifier tubes. 5U4, that's conventional filament. Comes off a dedicated winding and two plates, and that's your main B plus for the set. 360 volts coming off here. But there's also a 25Z6, and that powers a 150 volt bus. And the filament for this is part of the string. So it is series strung for the most part. We have two strings, 300 milliamps through this string, 300 through this string, and apparently we have a couple tubes, including the pitcher tube, that are 600 milliamps. So the two strings join together at this node, and we have two tubes after that to come back around. We have a couple ballast resistors in here to get the voltages up to the full line voltage. But then there are these tubes. It looks like there's a tap. It might be a tap on the primary side, and it powers these tubes. Those are, well, it's a mixed bag. Some of the tubes are the tuner tubes, the converter, RF amp, and the oscillator for the tuner. Those are the AFC tube and the vertical output tube and an audio tube in this mixed bag of tubes. I don't understand, but okay, fine. So yeah, I used a 6AG7 for the power amp. Go figure. That seems like an odd choice. It uses two 6BN6s. The 6BN6 is a tube that Zenith invented to simplify quadrature FM audio detection. Can basically take the signal for the FM audio signal and convert it right to audio frequencies with just two coils. So no ratio detector with its associated complexities. And that's what introduces that buzz or bias control that is characteristics of this design. But they also use it for the sync separator. I don't know if they were proud of their invention and they wanted to use it wherever they could. I don't know, maybe it makes a superior sync separator. I don't know, I was surprised to see it in there, but okay. Sure, why not? Likewise, 6AQ5 is a little odd for the vertical output, because it's normally that's what I would use or typically see for the audio output, not the vertical output, but okay. 6AB4 sync amp, also kind of an oddball. At least the horizontal stuff is rather conventional looking. So this is it. It looks a bit simpler on the schematic than it does in real life, but we'll muddle our way through. Here's the flyback, which may look a little crummy, but it looks a lot better than other Zenith flybacks I've seen. Hang on, I'll grab one and show you what I mean. A few years ago I went to an estate sale and they had several vintage TVs in the house and some chassis in the garage, and in particular there was a porthole chassis. At least I think that's where this came from. And I parted it out, and well, this is the flyback I found. This is fairly typical of Zenith porthole flybacks. This may be good for all I know, but boy, it looks horrible. It's kind of sticky. The wax they used over time seems to deteriorate. And maybe it gets a little moldy. It's certainly sticky, and it attracts dust, and it cracks, and it oozes, and yeah. So, this one doesn't look anywhere near that bad, but it is deteriorating. We have some cracks. It's flaking. It's a little sticky. Perhaps it could be hit with a heat gun and reflowed a little bit. I don't plan on doing anything until I get this start working. A safer route may be to just dab some Corona dope. It's a lacquer type substance that has very good high voltage insulating properties, and it's made for insulating electronics. So I could just slap some of that on and call it done. Yeah. Also a little bit hard to get at, so I don't want to monkey around too much under there, but I do have one cap I need to replace. So, I am going to leave you off here while I slowly start working my way through. I'm making slow and steady progress. Thought I'd touch on a few things that have come up One is the type of caps to use in certain instances. So the majority of the caps I'm using are these yellow guys, which are film capacitors, and that term gets thrown out a lot, plastic film caps. What are we talking about? Well, there's more than one type, and some are film and some are foil. Film means it's metallized plastic film. Think of a Mylar balloon. It's plastic with sort of a dusting of aluminum. It's not an actual thick piece of metal foil. And polyester has decent insulation for a very thin layer, so these yellow guys are polyester film capacitors, and you can get a lot of capacitance in a small package. For example, this is a 0.22 microfarad 630 volt cap. Here's what the original was, or a replacement. They had to use two of them together, 2.1s, to make a 0.2 rated for 600 volts. A little bit of a size difference. Why? Because this is real, actual metal foil, which is thicker than a few atoms of metal that are on this, and the paper is thicker than the plastic film. You get more capacitance as you get your two metal layers closer together, and dielectric constant of plastic versus paper comes into play as well. Okay, so that's why these new caps are so much smaller. However, check out this guy. That's pretty big, almost as big as the one that had been in there, but not quite. The one that had been in there was this guy. So why is that cap different? It's because that's polypropylene, and I believe it might be actual metal foil. I'd have to dig up the exact specs. I imagine a lot of you guys are familiar with these Orange Drop Sprague, which are now being made again, kind of boutique caps, the good old 715Ps. I believe these are also metal foil polypropylene, so they're big, much bigger. This is only a 0.1 microfarad, 400 volts. This is twice the capacitance at a higher voltage rating, and it's smaller. That's the difference. So why would I want to use an actual metal foil or polypropylene? Polypropylene has a little bit different, more robust characteristics than polyester, because some of these caps are worked harder than others, in particular ones that are in the damper circuit or couple a waveform to a yoke winding. Meaning there's more power than usual going through them. I believe that's what this big guy is up here. That's coupling the horizontal output to the horizontal winding on the yoke. So you want to use more robust capacitors in some applications. Oh, what else? Alright, so over here, some work had been done. That's where I noted earlier. Come on, focus. I'm still getting used to this new camera here. They had replaced some of the resistors and some of the caps. Or one resistor in particular, there was a big old guy. It was kind of flopping around, had electrical tape wrapped around it. Turns out, yes, it's newer, it's a replacement. It's also not the right value. It's supposed to be 400 ohms at 5 watts. This is 500 ohms. Now, I don't have one handy exactly, but I did put a 390 at 5 watts, temporarily tack that in. 390 versus 400, that's close enough. But I'd like to get a more robust type of resistor in there. See how this one is hollow? That you can get some air circulating through there and cool it down. Yeah, modern resistors can take more heat. That's why they're typically smaller for higher wattages, but I'd still like to get a little bit beefier resistor in there. Don't have any on hand. I'll pick one up and replace it when I do. Some of the caps in here had been replaced as well. For example, we had this, boy, what is that name brand? Cherry. We had a Cherry capacitor in there. I replaced that. This is an old replacement. I put a new yellow guy in there, and this is also an old repair. Those repairs were done around the video amp, and I believe, I'm sure that the main filter electrolytic has been replaced. I think that's it, though. I think everything else is original. Now, these caps, these old of bumblebee type caps. These are paper caps inside of a plastic tube, and while I was taking some out, I noticed some of them were already cracked. That's from the capacitor inside deteriorating, leakage current forms, they start to swell up a little bit, they can start to crack and ooze if they're oil impregnated. Well, since this one was already cracked, I went ahead and just busted off the side so you can see what's inside. So it looks just the same as a cardboard covered paper cap, where it's some waxy looking thin paper and metal foil rolled up. All they did is just put it inside of a plastic tube instead of paper. Now I've heard the end that has this thing that apparently was a vent end, or where they would force oil into it and then put a blob of solder on it to seal it off or some such. Take one that I haven't busted open. You can see there's a definite difference between one end and the other. I believe this is also the foil end. But these don't exactly seem oily to me, so I don't know about these being oil impregnated or not. And I cannot tell for the life of me. I'm starting to unroll this, which is the foil end, because the outermost layer is just paper. Does the outer foil matter? Oh, what a topic. I'm going to save that for a separate video if I ever get around to it. I've been thinking about doing one for a long time. Mr. Carlson did a very thought-provoking video a few years ago about the outside foil on a capacitor that sparked a lot of discussion about the topic in the forums and other YouTube videos. I get asked many times, am I orienting my capacitors right? So we'll save that for another video, but rest assured we'll get this set to work. So I'm going to keep on keeping on with replacing the foil caps while I still ponder what to do about the electrolytics. At least with getting some of these larger parts out of the way, things are opening up and I can see better down in there. We have the 3 main electrolytic cans. And no matter what, it's going to be probably the most challenging part of this project. I hope that's the most challenging part of this project, and there isn't something else like the flyback that's bad or anything like that. I'll keep considering that. While I recap, I will probably pick up when I have finished with the entire recap process. Here's a little progress update. I started working down around the horizontal output tube and tamper tube and kind of worked my way up in this direction. A few notable things. One, I'm using a little bit beefier caps for some of the replacements, in particular this guy. I'm using polypropylene film versus polypropylene foil versus polyester film. So, for example, film caps. It's thin metallized plastic, like a mylar balloon, where it's just a thin layer of aluminum vacuum deposited on plastic. Gives you a lot of capacitance in a small volume with a good voltage rating. So, for example, this is a 0.22 630 volt cap, whereas originally they had a couple 0.1s in parallel. That's quite a size difference there. These are actually, this is slightly more capacitance than these two and slightly better voltage rating. However, some of these caps carry, well, I hate to muddy the terms and say carry current or carry power, but, well, I'm just going to say it, that's what they do. In those cases, a better choice is polypropylene foil. You're probably familiar with orange drops, the good old 715P from Sprague, which are still currently being made. The name was bought up, I believe, by Vichy. And they are being made again more for the boutique audiophile market. But notice this is only 0.0068. And yes, it's rated for 1600 volts, but it's far less capacitance than this guy, but much bigger. Maybe a fairer comparison is this guy. 0.1 microfarad, only 400 volts. This is less than half the capacitance and a lower voltage rating than this guy, but it's bigger. Why? Real metal foil and polypropylene film, which I'm not 100% certain, might be a little bit thicker. I'm not sure, but the point is that these are more rugged. They can handle more power, for lack of, I don't know if that's technically the right term to be using, but they're more robust. So some of the circuits, I believe like this guy up here, where they use the ceramic tube cap, some of them carry, well, for example, this one I believe is the coupling from the horizontal output winding of the flyback to the yoke. So imagine there's a lot of current sloshing back and forth at a fairly decent frequency, 15.75 kilohertz. So you want to use beefier, more robust, more rugged caps there, because you might get a little spike or something, and you don't want that thin plastic film to rupture or fail. So similarly down in this area, they had a pretty sizable cap down there. 0.33 microfarad, only 200 volts. So I ended up using a polypropylene cap down there too. That's off the damper. The damper also sees a lot of spikes, and it's a good place to use more highly rated parts. Alright, so that's what's going on there. That's why you see a mix of some little yellow jobbers and some other different colored, different construction type caps. Now up in this area, yes, there was definitely some old repair work done. So I had noted earlier, this cap, this cherry cap, clearly looked different than the others in there, and yeah, it was a replacement. They did use the right value, but it's made in Japan. I don't know how old this is. It doesn't look like a fairly new one. It's probably 60s, I would guess. Anyways, I replaced that. And this was a replacement, and it's not the right value. It should be 400 ohms, rated for 5 watts. The wattage on this is fine, but it's 500 ohms. Now, I don't have one on hand, but I do have a 390, which is pretty darn close to 400. I think that's 5 watts, but I'm not 100% certain. So I got those in an assortment bag a long time ago. I don't remember. That's why I don't like buying generic parts so much for critical circuits, especially power users. I like to buy Dale, Ohmite, something where there's a part number on it and I can look up the specs. I don't know who made this. I don't know what the specs are. I'm really just putting that in there as a placeholder, so when I get the one that I'm ordering, I'll know where to connect it up rather than just leaving it clipped out of the circuit. And I wanted to clip it out of the circuit because I wanted to get its stuff around that area. So this actually is a video amp. So the one area where there was clearly some repair work done was around the video amp. It's a pretty important circuit. Definitely impacts signal or image quality, I should say. So I'm basically rebuilding that entire circuit. And then I want to move on to the power supply. So in other words, I rebuilt some of the more critical circuits. The horizontal circuit, I want to make sure the horizontal oscillator is running so I don't damage the horizontal output tube or the flyback. I did this area because there was old work done and I wasn't sure if it was right or they used the right values. That's why I worked on that area. The next area I want to do is power supply, which this is part of. So we have the 2 rectifier tubes in this area. Right down there. And then we have the 3 electrolytic cans, 1, 2, 3, which are oh so hard to get at. So I'm going to leave off here while I finish up work here and then figure out what the heck I want to do with that. Once that's done, and I want to replace a couple more these larger caps like this guy that are in the, like I said, it's a horizontal yoke cap, and then we'll try powering this up.